So let's say you're in this hypothetical scenario. It's April 12, 2022, and you were thinking about making a video for that Nostache thing being run by the Jack Film channel. Unfortunately, you've just realised the contest ends on April 13th. Tomorrow. There's absolutely no time to source editing software and learn how to do keyframe animation and think of a funny bit for the video, and then render and upload it to YouTube, Twitter, TikTok, or your choice of video hosting service, all before the deadline. Well, fortunately, your prayers have been answered. I'm pleased to announce the latest innovation from Couldnt, the Jax Films Nostache generator. Simply plug in a file name and an image of your choice, wait a few minutes, and the program will do all of the keyframing and rendering for you in one easy process, exporting a high-definition MP4 file, ready for upload or further editing. It really is just that simple. The program will be open source and available for free on Windows from my Google Drive link in the description. Try it today.
But wait a minute. What exactly is going on here? Well, to answer that question, we need to go way back. Way back. All the way back, in fact, to Friday. On Friday I released a video called Jax Films' Mustache Sketch, but badly 3D animated. It was a fun project. I've been learning Character Creator 3 and iClone for a while. I even used it to make a platformer game featuring a vague facsimile of myself the other day, and so this felt like the opportune moment to try to put my lack of skill to practice. All in all, it came out pretty well, and people seemed to like it, but I couldn't shake the feeling I was going down the wrong path. My whole thing is that I develop software, and by develop, I of course mean develop in the same way one develops an ear infection, and so it felt kind of forced to have my submission be an animation. I'm not an artist, I've never been artistically inclined, and I've sort of made my peace with that. So how could I turn this video editing challenge into a software development challenge? Well, all while I was editing that animation for the first video, I couldn't help thinking to myself, what if I made a program that just, like, auto-generated Nostache videos? Like, if I plug in a funny image, it outputs the video, but with that image obscuring all the mustaches, right? That would be fun, right? Sure enough, there's a number of software solutions that handle video processing. Given a PNG sequence as input, FFmpeg, the package I'm using to handle it, can create a video of whatever frame rate and in whatever format I want. Which is good, but FFmpeg is a command line interface, and asking the end user to type in a bunch of gibberish to make the funny isn't what I would class as a good experience. It sure would be great if I could just use CSS, the styling language used to make the internet look nice, and build my UI out of that. But then the generator would have to be a website, and energy bills in the UK are skyrocketing. I can't afford the costs of hosting video rendering software on the internet. If only I could shunt the computation costs off onto the end user and run up their energy bills instead of mine, thus insulating myself from the consequences of my own bad design decisions. But I don't think that's possible. Unless. Electron is a framework for the Node.js development runtime intended to allow software developers to create native desktop apps using HTML, CSS, and JavaScript, the building blocks of the internet. This is excellent for me because I know those languages and they're fairly straightforward to scale up.
You don't want to be like this.
One wave of a magic wand later and we have an okay user interface. Yes, I obviously rushed it, but I wanted to devote the majority of time to building the backend, because that's where the big programming challenge is going to be. I've never built a video renderer before, and in the course of trying to, I barked up a lot of wrong trees. A lot. You have no idea how much I've suffered. But to understand this, we have to go back to Metal Gear Solid 4. The year is 2012. To make sense of what a nightmare my development journey was, we should break down exactly how the desired end product works. The software takes 5 inputs. The first is a collection of 1224 PNG files, generated as a sequence at 23.976 FPS from the original Mustache sketch video. This will give us the base on which we can build the auto-generated mustacheless version later. The next is the audio from the video, which we'll put to one side for now and bring back near the end. Then there's the user input stuff.
Gross!
The first is a string, a collection of letters, numbers, and symbols used for the resulting file name. I don't know, gamingdingo.mp4. That's what I named one of the files. Fourth, the obscuring image. This is an image file that will be resized pseudo-dynamically and used to cover up the moustache in each individual frame. I'm going to leave the last input a secret because it'll be funny, don't worry. So the first step, we need to take those frames that we got from the video and superimpose the obscuring image over the top to cover up the moustaches. At first I used a library called GIMP, the JavaScript image manipulation program. That worked, but there was just one problem. It was too slow. It was like, I'm sure it's fine if you're making 1 or 2 images, but trying to scale it up to the level I was working at, it was too slow. I mean, I'm sure it's probably just me using it wrong, but in the end I stumped for a library called Sharp, and I found that gave me far faster results. The developers of Sharp promised high-performance image processing, and they weren't kidding. Compositing the images took like less than a second per frame, it was great. This isn't a sponsored video, by the way. Anyway, for Sharp to composite the images, it needs the picture the user wants to cover the mustaches with in a bunch of different sizes. So I got Sharp to generate 4 new images of those sizes to sort of cover my bases. It'll be helpful later when we try to cover that moving shot of Brock at the end as he moves towards the camera and his mustache gets bigger. Sharp has a function that will basically just superimpose one image over another if we tell it to, which is great, but it was then that I realized this project I was blithely stumbling into was a trap. To composite the images, Sharp needs 2 additional values, top and left, which represent how many pixels from the top and left of the frame the composited image is. Give it the right numbers in these fields and it returns a picture of Jack's films with the moustache covered up by my brand new cryptocurrency, HarryCoin, available now. This is where it springs the trap. Sharp needs these values for every frame, 1,224 frames, and I need a way to tell the program which frame it is that it's compositing, so I not only need to figure out these values for each image individually, but I need to structure the data in a way that JavaScript can understand. For this we need to use a file type called JSON, which looks like this. This is the 5th input. This contains the file name of every frame, how many obscures we need to cover all the moustaches, and where those obscures should be. I could have done this programmatically, what with I'm a coder or whatever, but no. I spent like 5.5 hours going through each individual frame and writing the JSON data by hand. After I finished it, I felt the most tired I've ever felt, and I caught coronavirus. So let's take a step back and review where we are. We now have a program that can turn frames of this video into frames with an overlay image over the top, and which can read this JSON data to tell the overlay where to go. That outputs a PNG sequence 1,224 frames long, and if we put that into Premiere Pro and add the audio back, we'd probably be done. But the end user might not have Premiere Pro, so we need to do the rendering ourselves. This is where all those wrong trees I mentioned a while ago come barking back. That phrase doesn't feel right. Before deciding on using FFmpeg, I got very distracted trying to make a separate library called Remotion work. Remotion uses a similar but different runtime called React, which is also used to make, among other things, native desktop applications. Among other things. Among Us? Anyway, Remotion has a lot of bells and whistles. You write the video in JavaScript and then it plays it back in your browser live as you edit and save it. It's really very cool. The problem is that it sort of worked for my purposes, but the video came out looking, well, bad. This time it was genuinely down to a lack of technical skill on my part, but I couldn't figure out how to get it to just play a PNG sequence without the frames coming out all broken. I would show you an example, but my dog ate it. So in the end, I used a library called Fluent FFmpeg. Fluent FFmpeg is a way of converting those ugly, boring command line instructions into cool, nice, human-readable JavaScript instructions, which I can then bind to other JavaScript functions, which I can bind to, like, the user interface I made at the start. You remember, you've got a good memory.
This right here is my favorite thing.
This is the bit where we bring the audio back.
Be funny now!
Now that's comedy.
Fluent FFmpeg is very cool because it lets you write render instructions like this in a list. We just chain all the inputs we want, the top one being the list of frames we've generated and want to render out, and this one being the audio file from earlier. But I was having some major trouble with it because no matter what I did, the video kept coming out at 25 FPS. This is a serious issue because it means the video always winds up out of sync with the audio and ends before the audio even finishes. That's bad. I'll never be taken seriously again. So I kid you not, I spent 3 hours diagnosing what on earth was wrong, and then ready to give up and start a new life as someone who actually contributes to society, I stumbled on one random Stack Overflow thread and realized my mistake. Turns out I put the input FPS call here rather than here. I didn't think it mattered. Turns out in this variation I was setting the frame rate of the audio. Audio does not have frames. So when I budged this up to modify the actual video, it came out entirely like I wanted it to. So without further ado, here is the mustache sketch, but auto-generated by a computer program featuring HarryCoin.
Okay. Yep. All right. Bye. Brock's not coming.
What? But he knows we're supposed to play Be Funny Now, the free-to-play party game on mobile and Steam.
You don't think I know that?
Maybe he stayed home to join a public lobby, matching with up to 7 other players.
Or maybe he's doing the daily question. It's like a global battle royale, but every day.
And Jack, we could always play with just the 4 of us, either in a private or public lobby together.
I know. It's just that Brock said he was gonna come, and he violated our trust. And frankly, I don't know what I'm gonna do.
Be Funny Now, anyone?
Brock!
Be Funny Now, coming soon to iOS, Android, and Steam. It's free!
What a great video. So yeah, am I upset that this software it took me so long to make will become obsolete like 2 days after this video goes out? Honestly, not really. I'm pretty happy I even figured it out at all, and I've learned a few useful insights I think I can apply to future things. That said, if Jack's Films could extend the deadline by like another week or so, that'd be very nice. If you want to try it out for yourself, there's a link in the description to download it for Windows. I'm going to try to upload the files to GitHub as well, so people can make pull requests or whatever if they don't have literally anything better to do. A few caveats. You will need FFmpeg installed on your machine to make it work. There's a link in the description for instructions, and FFmpeg is packaged with the software. The exported video doesn't work in Windows' Films and TV program or Windows Media Player. It works fine in VLC Media Player and editing software and on YouTube though. It also comes with an EULA that you agree to by downloading it. This is very prototypal, largely untested software, so I give no warranty whatsoever that it works on any computer other than my own. It's also rendering software, so it may have a computational power requirement that if you're using one of those like robot gaming laptops from the early 2000s may be beyond your capacity. Anyway, thanks for watching guys. If this video gets 500,000 likes, I'll make the AI generator next. As always, if you have any feedback about my work, make sure to leave it somewhere I won't have to read it. Goodbye.